35. It wouldn't.
Couldn't fire it up again.
No.
Yeah.
So that's DC to DC converters. What else are we going to talk about today?
Well, we could talk about our new motor and controller that we're looking at for our project we were talking about, the Speedster 2.
Let's get it out here and show them what we got. This is kind of cool.
All right.
Okay, Brain, this is kind of a find. What the country used to need was a good 5-cent cigar.
Good 5-cent cigar.
I've heard it said.
That's right.
Actually, I've smoked some 5-cent cigars. I don't think we need that at all.
We're not going back on a 5-cent
What the
cigars.
EV community has needed for a long time is a good AC induction motor and controller at a reasonable price.
Absolutely.
In the last month, one's come onto the market, and it's kind of cool. It's a little unusual.
Right.
I haven't run it in a car, but I think it's kind of cool.
I do too. I think it's really fine.
This is a low voltage AC drivetrain. We got it from some guys at Thunderstruck EV.
Right.
They're kind of the first dealer for it. The company that puts it together is
High performance golf cars
There you go.
out in Ontario, California.
right, and they've been working on EV. These guys love EVs and cars. They've been playing with it for a long time, and they've come up with this motor, and they've gotten Curtis to do a controller that matches up with the motor. This is a new Curtis controller. Curtis, for those who are not familiar with him, probably, I would say, on EV album, there's 2,500 cars. I'd say half of them use Curtis controllers. I'm not a huge fan of Curtis controllers on account. I tried to order one time. It took 3 months, but they. And I never did get it. It's kind of like the VAC Motorsports thing. American manufacturer. They are interested in OEMs, but actually they make forklift controllers and golf car controllers.
Right.
And a lot of DC series motor type controllers. They have a new one. This is the model 1238-7501. And it is a true three-phase AC inverter controller with regen. It's programmable. It's all the things I wanted in a controller with one problem.
And what's that?
It's limited to 130 volts.
That is true. That is true.
And so it's not very high voltage.
Right.
So you're dealing with pretty big cables, and you're not going to get a tremendous amount of power. They're calling this a 52 horsepower peak motor.
Right.
I think we can do quite a bit more than that, even with this controller. This will do 550 amps.
Right.
At 115 volts, they say you can push it to 130 is about where it goes into shutdown. But it'll give us a regenerative braking capability, a nice motor that's smaller than the net gain Hort 9, has the same shaft and the same face mounting, so we can use pretty much the same adapters.
These standard adapters that are out
as
there.
a Hort 9, and this is an AC induction motor. No brushes of any kind, no maintenance. No, you don't deal with all that. Here's your three terminals. Here's the 3 from the controller. Here's the 2 from the battery pack. And then you have a plug over here with 300,000 things that go into it.
Right.
And among them are your throttle control. It'll put out a brake light signal if you want to run it, where when you take your foot off the accelerator, if it goes into regen, and it'll turn on the brake lights for you as if you'd put on your brakes. That's a neat feature.
Right.
It'll also use a brake pot, 5K pot, to set the regenerative braking function. And so this allows you, when you're going downhill or put on the brakes, to put some of that energy back in the pack. It'll give us a little better range, perhaps on a little smaller pack.
On a little smaller pack, yeah.
The whole package, what do we pay? $4,600.
$4,600, yes.
And so that's in the league with a net gain series motor, 17 or 1,800 bucks. Our Kelly controller was about 2,000. This might be a few ducats more, but you get an AC system.
AC, yeah.
These AC induction motors work. They don't have commutators. They don't have brushes. The counterforce in the rotor is actually induced in coils by the coils in the stator. That's why they call it an induction motor. So you don't have all that mechanical wear components. You've got two bearings.
That's really it.
And a shaft. That's your three moving parts.
Yeah, that's right.
AC induction motors, there have been samples of these, certainly built some time ago, obviously, that have run for 100 years without maintenance. Now that's an old style motor that you pour oil in a cup to do the bearings and so forth. But they've been in continuous operation for a century. And so that's these are very robust motors, very durable, no maintenance. They're a lifetime motor because they're simple. They've got two pieces and two bearings, and that's pretty much it. To drive an AC motor is a little more complicated. A controller, your basic mission is to convert your accelerator pedal signal into a controlled forward motion, and you want to do that being as energy efficient as you can.
Right.
What's evolved over the years is what's called a pulse width modulator. And that's basically, you chop that DC into a square wave. It's on for a certain amount of time, and it's off for a certain amount of time. And imagine them being, a square wave would be equal amounts of time. But if you turned it on for a quarter of the time and off for the other 3/4 of that period, you would have half as much voltage.
Right, exactly.
If you turned it on for 3/4 of the amount of time and off for a quarter of the amount of time, you'd have essentially 3/4 of your pack voltage there. So if you're doing a 144 volt pack and it's on for 3/4 of the time, you've got about 100 volts to the motor. It's what it'll see. You do this at 15 or 16 kilohertz. And so the motor can't respond that quick. It's blind to the AC component of that.
Right.
It just sees the average DC. And so you can get efficiencies up over 90% in basically changing the voltage to the motor using this pulse width modulation concept. AC is a little trickier. It does use pulse width modulation. It also varies the current or the peak on each of those. But it drives the motor by rotating the phases among these three phase inputs, which are tied to different coils around. And you basically rotate it around the motor. And the shaft has to keep up. So you have three pulse width modulated controllers built into one.
Pushing it along.
And then to do the regen and to keep track of that, you kind of have to know how fast the motor's turning. So there's a little encoder back here on the back end that you have to hook up. This tells our controller how fast, actually gives it position information of the shaft. And because the rotor kind of lags that rotation by a little bit, it's called slip. And so driving the motor is simpler, but the driving electronics is 3 times plus more complicated.
Complex,
And you still have to do this at power levels.
Right. Right.
But it's 3 times more complicated simply by having 3 PWMs. But then there's a little bit of math involved.
Yeah.
The current algorithm is a vector algorithm to calculate exactly what you need to do to drive that shaft with maximum torque at any given RPM and so forth. So that they're pretty much microcontroller